So welcome to yet another video on genetic algorithm. This time we'll discuss upon on the evolutionary algorithm, genetic algorithm. So this algorithm is based on the concept of survival of the fittest. So let's try to understand this problem with a flowchart. So this problem, the first step is to initialize a random population, and within that we select the best set, and which is performed in the selection step. We select which particular chromosome has the best value or best value for fitness function, and then we'll check for the convergence criteria and perform the crossover operation, and then we'll mutate the particular chromosome, and then we'll repeat the step until we reach the convergence criteria. So we'll go back to selection and then check for convergence. If it's all right, then we stop it. So let's try to understand with a problem. So here we have a problem where we want to maximize a function f of x square minus 5x plus 6 within the range 0 to 30. So let's get started. So first step is to initialize a population. So here I have chosen 4 particular chromosomes, and I have represented them in binary representation. Now why binary? It's because it's easy to perform those operations such as crossover and mutation in the binary representation. So when we get there, we'll be able to understand that. So the second step is to select the best one. So in this, what I've done here is I have calculated the x value and then evaluated it on the function which was given in our problem, x square minus 5x plus 6, just a fitness function, and then calculate the expected value. Now, expected value is the total number of samples that I have taken, which in our case is 4, multiplied by the probability. So how do we calculate the probability? What we do is we divide our fitness function with the sum of all the fitness functions. So in this case, it is 110 divided by 874, which equals 0.1258. So in this case, 462 divided by 874 equal to 0.52. So if we multiply these two values with 4, we get these values. And in this step, the most important thing is to find the best chromosome which has the highest expected value. In this case, the second one has the highest expected value, which is 2.1144, and the minimum is 0.1372. So what we have to do here is we have to replace this minimum third chromosome with the second one in the next step. So before that, we'll check for the convergence criteria. Of course, in the first step, it's not going to converge. There are so many convergence criteria, and it is more based on the problem that we are going to solve. So in this problem, we'll concentrate on the third convergence criteria, which is to check the difference between the best individual of the current population and the best individual so far. And we check if the difference between these two particular individual, and we want it sufficiently lower or even 0. So this will be the convergence criteria for this problem. So after we do that, we have to do the crossover step. So what we do here is we'll select those particular chromosomes from the selection, and notice that the third one is replaced by the second one here. And what we will do here is the crossover. We have to select the crossover point, which is now in our case, which is randomly initialized. And in our case, I have taken the 4th value. That means at the 4th step, I will change the value that goes after that with the 4th or the 5th value in the second one. So if I do the crossover between 1 and 2, which is explained here. So let's say the crossover point is 4 here. So 1, 2, 3 and 4. After that, this particular one goes to this chromosome, and this 0 from the second chromosome comes to the first one. So after that, it results in this value. So after that, I have to calculate again the x value and the fitness function. Now notice that the sum of the values has increased. It was something 800 that in the first one after the selection process. Now here at the crossover, we see we have increased our value, that is, we're going towards convergence. So the next step is to mutate. So mutate, we locally find one particular string, and we select this. So in our case, in the first one, I have taken the 0 and replaced it with 1. So if I mutate that gene, I have to calculate again the X value and the fitness, and notice that some of the values is still more increasing. So after that is completed, this is the end of iteration 1. Now recall that we have to again follow the selection process. Now in this, the value with the highest probability is the third one, which is 1.264. And now if you check for the convergence criteria, you see at the last time our best individual was 24 value. Now at this particular iteration we see it is 27, and the difference is 3, which is not trivial. So we'll continue our iterations. So similarly, I'll keep on going and do the crossover operation, and I see still the sum of values is increasing, and I'll do the mutation, and again I observe that the value is increasing. So I have to keep on doing this repeatedly. This is where a computer or program, if it is implemented in a program, it can be completed in fraction of time. So with this, it is the end of iteration 2. So if we do this continually, we have this process of selection, crossover and mutation at particular value. When we find a particular individual whose value is nearly similar to the value in the previous generation, then we can say our algorithm has sufficiently converged to a solution. So with this, we conclude here.